Hello everyone, Basil here with another experiment from the COSMOS Toolkit. So today's experiment, I'm just going to introduce the PowerPoint that introduces Dijkstra's algorithm to your student. So the way you access this PowerPoint is by clicking on Computer Science from your COSMOS Toolkit, going into 6th and 8th grade, clicking on Introduction to Algorithm, and all the documents related to this experiment are online, including this PowerPoint. So let's talk about this PowerPoint. So this is an introduction to Dijkstra's algorithm, uh, but we are assuming that students understand what an algorithm is. And you should check my other videos to see how to introduce algorithms to your students. So the way this lesson starts off is with a short little activity where students have to find the shortest distance between these points on a graph. You can do this activity two ways. You can differentiate, you can give students a blank grid and ask them to plot the points on the grid and then find the shortest distance between the points. Or you can have it pre-filled and just ask the students to find the shortest distance between these points. After this activity, you can have a little discussion. What was the best way? What was the most efficient way? Were you looking for, how many boxes you had to go over? Things like that. So have engaging discussion with your students. After that, this slide, I like to always give like a historical perspective on things, especially in computer science, because we take a lot of these things for granted, and students need to understand that these technologies did not exist less than a half a century ago. So this is like a background perspective on why this topic is relevant. Then we move on to a little review of what algorithms are to refresh the student's memory. Or if someone was absent, they can catch up by watching this video. Then we move on to actually talking about what an algorithm is, review again. It's like a recipe. You have a little class discussion back and forth, ask students questions, and have them explain this in their own language. So you know that they really grasp the concept, they really understand it. After that, we move on to another efficiency problem, the traveling salesman. So the students are not solving this problem, but it's just giving them another perspective, another entry point. So this problem, a salesman has to travel to different cities to sell their product, but they cannot, waste their time by visiting the same cities. So they have to find the efficient route going from one city to all the cities that they are assigned. So this is the map of the US where you visit all the major cities without doubling or coming back to any of the cities. So this is the most efficient route. So you talk about how can you find the most efficient route, the cheapest route, or has the fewest time. You have a little discussion about that. Then you move to on to asking student how does optimization work. Computer science is all about optimization. And then we introduce Dijkstra's algorithm, um, what Dijkstra's algorithm is and what does it do. There's a small video about how Dijkstra's algorithm works. And, obviously you can pause the video and have questions, ask questions to students if they understand, to gauge them and see what's their current understanding. After the video, we go over, you ask your students to summarize first, and then you go over some of the points that they probably will mention about Dijkstra's algorithm and how it's used and where it's used. After that, there's another video to reinforce the information because it's another entry point and it has a little different perspective, introducing what the Dijkstra's algorithm is and how we can solve it as well. After that, you do a step-by-step guide on how, as students, we can fill in a grid using, fill in a chart using Dijkstra's algorithm, finding the most efficient route. and you introduce the steps, and then you can do this small activity if you have to go from your house to all of these connected locations, and what's the most efficient route to go to the gas station, the movie theater, Divya's house. So this is just an entry point into the lesson. Then you go over this other problem. This is like the first activity, and you can see a separate video about the activity as well. So this is just a basic activity where students now can actually go on and use Dijkstra's algorithm to find the efficient route. After that, you introduce this problem. This can be the majority of the class where students work together in a team of 3 to 4 students. Anything over 4, it'll get complicated. You know, I like to keep my team small. So 3 to 4 students working together to solve this problem and finding the shortest route from Rochdale to all the other connecting cities. And there's a whole activity with the relevant document in the folder, and you can find them there. This is what they will students will get, and this is starting them off. Okay, so from Rochdale to Rochdale, it's 0 distance, so this is the shortest route, and then from Rochdale to Manchester is 25, and so on and so forth. And they have to find the distance to each of the connected city. So give students ample amount of time to solve this activity. It might take over, you know, after you introduce the lesson, it might take 15 to 20 minutes at least to do this in a group of 3 to 4 students. You may assign this as homework as well, but I find it more effective if students work on it in class with their peers. So then you just summarize the lesson, you just do a little reflection, and you can ask them to write a reflection as well, what they learned today. It's up to you. And if you have time, or if students finish early, I always try to include additional resources so students can have background knowledge, or they can do an extended activity. So students can watch this video on how the internet works and how cables and Wi-Fi works. And they can also watch additional video about how the internet is connected and how things are routed from different networks. If, you know, this is an extended activity if you have time, but most of your students in a class period will not have that extra time. But just in case, I like to have additional resources available to students. So that's it for today. This is a review of what Dijkstra's algorithm is and how you would introduce it to your students. Once again, this is Basil signing off. See you next time. Thank you.